In the next question, we are going to find how many electrons are there in 1 kilogram of water. So as you see in the picture, we have 1 kilogram of water and we are going to find the number of electrons in this 1 kilogram of water. The chemical formula of water is H2O. So we are going to find the atomic number and mass number first. Atomic number of water, H2O. In the water molecule, we have hydrogen whose atomic number is 1, but there are 2 hydrogens. So 2 times H. So 2 times 1 equals 2. Then we have 1 oxygen there. Atomic number of oxygen is 8. So total we have 8 plus 2, which is 10. Similarly, mass number of hydrogen is again 1. So 2 times hydrogen will be 2 times 1 equals 2. But mass number of oxygen is equal to 16. So now we have total 16 plus 2, 18. So atomic number of water, H2O, is 10 and mass number is 18. Now this 18 has one more meaning. This means there are 18 gram of water molecules in a mole of water. Mole is the amount of a substance that you learn in chemistry. 1 mole of anything contains 6.022 times 10 to the power 23 particles. This is called the Avogadro number. You have learned this in chemistry. So we need this number. Again repeating, mass number 18 means it contains 18 gram of water per mole. Let's do one more thing here. Let's change this into kilogram. So it will be 18 divided by 1000. That is equal to 0.018 kilogram per mole. Okay. Now let's go to the next step. In the next step, we are going to find the total number of atoms in 1 kilogram of water. The total number of atoms in 1 kilogram of water. So the mass here, mass given times the Avogadro number. I am going to write A here for Avogadro number, divided by how many moles per gram. Okay. Mass per mole. So that will be, in the question it is given 1 kilogram times Avogadro number is 6.022 times 10 to the power 23 over, what is the mass per mole? 0.018 kilogram per mole. So when you do this, you will get the total number of atoms. When you do this, you will get the answer as 3.34 times 10 to the power 25 atoms. Now let's find the number of electrons in these number of atoms. So for that, what we do is, we will multiply the atomic number with the total number of atoms. So atomic number times total number of atoms will give you the number of electrons. So that will be, atomic number is 10. 10 times total number of atoms, 3.34 times 10 to the power 25. So the answer will be 3.34 times 10 to the power 26 electrons. So this is how we do this question. We have a similar question in the textbook also. If we wanted a block of iron of mass 3.25 kilogram to acquire a positive charge of 0.100 coulomb, what fraction of the electrons would we have to remove? Here we have to find the fraction of electrons. So anyway, we have to know the total number of electrons. So the first part is same as our first question, the previous question. So let's do that. For iron, the atomic number is equal to 26 and the mass number is 56, which means it has 56 grams per mole, or on changing it into kilogram it will be 0.056 kilogram per mole. So this is the meaning of mass number. Okay, now our next step is to find the total number of atoms. So in the question it is given the mass is 3.25. So 3.25 times the Avogadro number. 1 mole contains 6.022 times 10 to the power 23 particles divided by 0.056 kilogram per mole. So now when you calculate this, you will get the answer as 3.5 times 10 to the power 25 atoms. Okay. Now the total number of electrons. Total number of electrons means the atomic number, that is 26, times the number of atoms, that is 3.5 times 10 to the power 25. So you will get the answer as 9.09 times 10 to the power 26 electrons. So we got the total number of electrons in this particular mass of iron. Next, in the question it is given that a positive charge of 0.100 coulomb is created. We have to find the number of electrons that iron loses for getting this particular charge. So the number of electrons that it loses, I am going to give it as delta E. The number of electron that is lost for this particular charge. So N is equal to Q over E, our first equation. So Q is 0.100 coulomb divided by the charge of electron 1.6 times 10 to the power minus 19 coulomb. And here we will get it as 6.24 times 10 to the power 17 electrons. So we have total number of electrons, this, and the fraction and the electrons which is lost for getting this particular charge, that is this. Now let's find the fraction of electron. The question is asked to find the fraction of electrons. So the electrons lost divided by the total number of electrons, that will be 6.24 times 10 to the power 17 divided by this number 9.09 times 10 to the power 26, and you will get the answer as 6.87 times 10 to the power minus 10. So this is the fraction of electrons.